answer the question of whether or not this is something you want to use. All right. So, first question you're probably asking is like, okay, so what is Kotlin serialization? Basically, it's a data serialization library developed by JetBrains, who also do Kotlin and Android Studio. And the plugin, it basically consists of a compiler plugin and a runtime library. The compiler plugin is actually it actually sort of generates serialization code for each object that you want to serialize. And the runtime library is responsible for taking that code and actually doing the serialization. It supports a few formats sort of made or out of the box. For this talk, we're specifically going to be focusing on JSON, but if you're interested in some examples for some of the other formats, there's lots of examples on the official documentation. And just something to be aware of with the library, it is still under heavy development, so it's experimental, and the API is subject to change from version to version. And so just be aware that sort of what the API looks like now might be completely different for version 1.0. Okay, so the next question is, how does it work? Well, it's pretty simple. So any class that you wish to serialize, you mark it with the serializable annotation. And what this does is gets the compiler plugin to generate code to actually serialize each part of the object and all the data in the object. And if you need to have any serialization behavior that isn't met by the code that's generated, you can write custom serializers yourself in order to get behavior that you're looking for if the generated code doesn't meet your needs. Custom serializers are also really handy for third-party classes or third-party libraries that you're wishing to serialize. So if you don't actually own the class that you're trying to serialize and you can't make any changes, custom serializers can help you out there as well. Okay, so sounds great. But how do you go and actually set it up? So it's pretty simple. So really, at first it's just a matter of adding the compiler plugin to your project's build Gradle file. And then once you've done that, it's just a matter of applying the plugin and adding the dependency on the runtime library for the specific module that you're looking for. And so, all right, I can tell just from the audience that you guys are super psyched, and the moment's finally here. 2 minutes in, we're actually going to serialize in JSON. All right. Okay, so in order to do that, a couple of things we need to do. First, we need to create a JSON configuration object, which we will then use to instantiate a JSON object. So pretty simple, just two kind of simple lines here. The JSON object is the one on the bottom here, is what we will actually interact with to do the serialization. That's sort of the entry point to the library. And the config is what holds the configuration for our serialization. So it holds information about how to serialize certain things. You can make your own configurations, but there's a couple that sort of come right out of the box that are pretty handy. The default configuration is the one that's recommended by JetBrains, but it doesn't have any guarantees between versions, so it may change from version to version. There's also a stable configuration, which is guaranteed to stay the same from now until eternity, but it's not the officially recommended one. At the moment, the stable and the default configurations are actually identical, so it really doesn't matter, but again, that may change as time goes on. So this just gives you sort of a list of the properties that are included in the JSON configuration object. It's just a series of properties that you set when creating the object. Things like pretty print, what you want your indent to be, if you want to encode defaults when you're doing the serialization, things like that. And the nice thing about the JSON configuration is that it's a data class, and so that if you only want to specify one or two of these parameters and want to leave everything else the same, you can easily do that by just copying it and specifically changing the properties that you're interested in. So in this case, we're taking the default configuration, but we're choosing not to encode defaults, and we're just going to turn on pretty printing so it'll look all nice and pretty in the console. Okay, so we've kind of got the background done. So let's go through some basic examples. So let's say we have this class here that represents specifically a baseball player, but I suppose it could be like any athlete, I guess. It's just basically a very simple class. It's just got a first name, last name, and a number that they wear on the uniform. And so if we want to serialize this class, as you can see, we've just marked it as serializable. And to actually go and serialize this, we interact with the actual JSON object that I mentioned a little earlier, which is, and we call a method called stringify on that JSON object, and that just takes the model and puts it into a JSON string. This method takes a couple of parameters. One is the serializer for the player, or for that class that we're serializing, and that serializer there is what is generated by the library, and it's actually generated on the object's companion, so you can just call it sort of in a static context like this. And then we pass in the player, the actual instance of the class that we want to serialize. And when we do that, it just puts it right into JSON, which we all understand. And so it's just basically like a strict mapping of each field. So that was cool, but if you noticed, it basically just took each field name and just translated it directly. But in most cases, we probably want to use snake case, for example, for our field names. And so if you want to give an alternative name for the property, then you would toss this serial name annotation on it and give it what you want to call it. Call the same stringify code, and now we get it where our field names are looking how we want them. And of course, probably the next question is, how do we do the reverse? So we've just got our JSON that we've stringified. And now what we do is, it's similar, but we just call JSON.parse. And so it passes in we pass in a similar set of parameters. We once again give it the serializer that's generated by the library, and we give it the actual JSON string implementation, and that just spits out a model representation of our class. So that was really cool so far, but let's say that we have, that was just specifically the case of serializing one object. But let's say we have a list of objects, which we often do when writing apps. So in that case, so once again, we have our object here. And in this case, if we want to specifically serialize a list, there's actually a convenience property that comes with the generated code called list. And what that does is that's able to actually serialize our object, or a list of objects, using that same serializer for that individual class. There's actually a few different of these convenience properties as well for whatever collection you're working with. There's set, there's map, there's things like that. And there's also, probably a good time to mention, there's also a series of primitive serializers that come with the library, so for things like strings and booleans. So if you ever need specifically, so for whatever reason, if you needed to reference a serializer for, say, an integer, you wouldn't do like integer.serializer. You would, there's a Kotlin serializer they provide called int serializer or something like that, which you can just use in that case. Okay, so we've sort of seen a few examples so far, but what if we have a case where we have a property that we optionally want to include in the serialization? So we can achieve that by giving properties default values. So in this case, we've added a nickname field to the player class, and so now, I mean, that should be self-explanatory. And it's a string, and it's optional, so a player can have one or not. And when we go and actually stringify once again, you'll see that it's sort of included as a null value. But if we don't want to include it as a null value, then using the same object, we can actually change our JSON configuration, which I spoke about sort of on slide 4, where we set up how we parse our JSON. So we could actually copy our, say, an existing configuration and explicitly set encode defaults to false. And so what this will do is if a property is equal to its default value, it will not be included in the serialization. And so now, when we do that same JSON serialization, we're now noticing that we're missing the nickname, because it's equal to its default value, so it won't be included. So now you're probably saying, okay, but that's cool, but what if we have a default value and we've set it up that way, but there's a specific default value that we do want to include? In that case, sorry, it would help if I did that. In that case, the required annotation is going to help you out there. So in this case, we've added just a Boolean field, whether or not the player is active or not. Default is true because that's a reasonable default. And given the same JSON configuration, if we're explicitly saying do not encode defaults, we notice that when we serialize it, the nickname, or sorry, the active field is encoded, even though it's equal to its default value, because we've explicitly marked it as required. Okay, and so moving along, so now you're thinking, well, it might not be, but I was thinking, what if you have a field that you never want to include in serialization? In that case, you use the transient annotation. So in this case, we've added sort of an ID field to our class. ID just sort of being like representing like a local ID that's, we don't really care about sending to the server or anything like that. And we mark it as transient, we do the serialization, and as you can see, it's excluded from the JSON. A couple of things about the transient annotation to be aware of. One, anything marked with transient has to have a default value in the class, just so that when we're reconstructing it, or the library is reconstructing it, it knows what to set that value as. And be careful which transient annotation you use, because there's a Kotlin X serialization, which is the one you want, and there's a Kotlin JVM, which is not the one you want. And so when I was doing this the first time, I just saw Kotlin, I'm like, yep, that's the one, and did it. And then I sat there for 10 minutes trying to figure out why it wasn't working. So don't do that. Okay, so we've been doing a lot of examples on just sort of single classes. What if we have like sort of a nested class? So in this case, we've got created a team class. We've got just a city and a name of the team properties, and we've just got a roster, which is just the list of players that play for that team. In that case, we would do exactly the same thing. We'd call JSON stringify, we'd pass in the serializer for the team class, and that just gives us our list of, it just serializes everything as we would expect. So just because the player, all this list of players, that's serializable, the outer class is serializable, so everything sort of knows how to work together. Pretty standard. So what if there's a case where you have a generic parameter that you don't actually know what you're trying to serialize ahead of time? So in order to sort of, or to show that case, let's say we have just sort of a data message class here that has some sort of title, and it's got or just a payload that's of a generic type. So when we put serializable on the message class, we don't actually know how to serialize T yet, because we don't know what it is. So in this case, let's say that we have a message that contains a data type of player, which we've been working with for the last 10 minutes or so. And when you actually go to stringify it, you will notice that the message serializer actually takes a parameter for a serializer for each type that it's trying to serialize. So if this thing had 3 or 4 different generic types, you have to pass in the same number of serializers for each type. And so this way, it just delegates responsibility for serialization to a class that we know how to serialize. And so when we do this, it just does it. We know how to do it, and we get exactly what we're expecting. So we just get our title and our data is serialized as a player, no problem. So moving along, let's add another field to our class here. So we've now got a position field, which represents positions they could play on a baseball field. And so it's just basically a series of positions with just an integer ID representing each one. And so when we try to serialize this, just by default, it will just serialize the name of the enum in the serialization. So for most cases, that's probably pretty good. But let's say we have a situation where instead of actually wanting to do this, what if we want to do actually encode the ID instead of the name? So in this case, instead of encoding pitcher, we want to do 1, so we know that that's the ID for pitcher. So in that case, the custom serializers can help us out to get this kind of behavior that we want. So this is a custom serializer that we can write for the position class, which is what we're trying to serialize with custom behavior. You basically need to implement a K-serializer interface that comes with the library and give it the type that you're trying to serialize. The two sort of important things to keep note of here is you have 2 methods to work with. One is the serialize method, and that just tells you how to take your existing object and how you want to serialize it. And subsequently, you have the deserialize method, which takes your JSON and how you want to put that into an object. And so here, all we're doing is we're taking the ID from the position object and encoding that integer. And if we're deserializing it, we're taking the decoded integer and creating a position from that integer. So pretty simple in this case. And now when we actually serialize this, when we go to serialize the position class, we mark the position class as serializable, but we explicitly state that we want to serialize it with the position serializer, which is the class we created on this slide. And when we actually do the serialization, we see that it shows up as 1 now, which is what we were looking for. So any picture is going to be encoded as 1 and vice versa. So moving along, let's now add a handedness property down over here. And we've got 2 of them, and basically it just means which, either left or right-handed, would you throw or hit a baseball. So we're representing those by a sealed class, and we've got objects for left, right, and switch. Switch being you can do both ways, and if you can do that, you're probably making a ton of money, which is pretty good. And when we go to actually serialize that class, we run into our first problem. And you'll notice that the bats and the throws fields are actually serialized as empty objects. And this is a problem because as we notice, we can see over here that left, right, and switch are defined as objects. And this is the problem with the library, is that it doesn't know how to serialize objects. And this is actually a missing feature for the library at the moment. And so it doesn't know how to do this. So once again, we have to turn to a custom serializer. So in this case, it's pretty simple. In our serialize and deserialize methods, we're just taking the actual object and encoding it to a string and vice versa. And now when we actually do the serialization, it'll show up properly as left and right. So it's super easy to work around just with custom serialization, but it's really annoying, like the fact that you kind of have to do this. And we ran into an issue with like this in a more practical example. We ran into an issue of like this at work where we had a series of API responses that we were modeling as sealed classes and objects, and then we had to serialize that, and we ran into a whole problem because we couldn't. And so we had to write custom serialize for each object, which was very annoying. Looking at the repo, this is a known issue in like the Kotlin repo, and they are sort of working on it, and it's been added as a required feature for version 1.0 of the library, but it's just not available yet, and it's just something to deal with if you choose to use the library. So far we've just been doing a lot of sort of serializing of objects just in isolation. But considering we're a room full of Android developers, we probably want to know this. We probably know the answer to this question right here. And obviously the answer is yes, because obviously Jake Wharton has written a converter factory to use this with retrofit. So it's really simple to use. It's basically just you add the dependency, and then when you create your retrofit instance, you use library adds an extension function onto the JSON object to actually create a converter factory, and then you should be good to go. So in order to test this out, I used the MyJSON server service, which basically just lets you host some fake data on GitHub and then hit a REST endpoint, and that data that you host on GitHub will come down through the endpoint. And so I put a list of players up there on GitHub, and then created my retrofit instance to actually get a list of that list of players, or to get a response to that list of players. And to test it out, I just wrote a test that said, okay, like I've got my list of actual player objects that represent exactly what's online, and I've got and then I just actually do the retrofit call to get the actual response, and then I just check to see if the two are equal, and it was. So perfect. So I've been talking quite a bit about all the things that you can do here with the library, but there are some issues in addition to the object serialization. So just let's talk now about sort of things you probably should be aware of if you want to sort of use the library. So things to look out for. When you are dealing with classes to serialize, the constructors cannot have parameters. They have to have explicit properties, whether it be vals or bars. So, I should actually specifically mention that if you want to use the serializable annotation on the class, it has to have properties and not parameters in order to do the serialization. Again, objects aren't serializable. Sealed classes can cause real problems. So they do work out of the box, but the way it's sort of implemented is it's basically, when they're serializing it, they just sort of throw a type parameter on there, which represents what type of sealed class it is in your hierarchy, which does work, but if you want any sort of custom behavior, it can be, I've had a lot of issues trying to trying to serialize that into sort of the format that I wanted. And you also have to use a more advanced sort of polymorphic serialization, which is a bit further advanced of what we're talking about here, but it's just a little more of an advanced topic, and it caused me a lot of issues. And it could just be that I was doing everything the wrong way, which is very possible, but it was just something it's still development time that you have to invest into figuring it out. The docs can be out of date in certain spots, so I mean, the documentation is quite thorough, but in a few cases it points to maybe deprecated or obsolete APIs. It tells you it tells you that you can't do things that you actually can when you actually go and try them. So just something to be aware of. Like I was trying to figure something out, the documentation was telling me not to do it, and then I just tried it, and I was like, oh, look at that, that's cool. And if you happen to see errors that don't make a ton of sense, like when you're trying to work on your object, such as your object isn't registered for serialization or something like that, 80% of the time, if you do a Gradle clean, it's going to fix it. And so again, pro tip along with the transient annotation: if you see something that doesn't make sense, try cleaning it first, and it very well might solve your problem. Okay, so we've been going on for 15 minutes or so, and you probably just want to know, okay, like, should I be using this or not? And I've been teased. Well, I'm like one of those TV shows that keeps teasing you before a commercial. And I'm going to make you wait a little longer because we're just going to quickly recap the pros and cons. So pros. So the library, it's open source, and it's got a pretty active community. Like the repo is very active. There's a lot of discussion going on. So JetBrains has put a lot behind this. It's one less third-party dependency to worry about. This is quite good if you've got a Kotlin native or Kotlin multi-platform project, and you're trying to limit your dependencies that you need to expand to all the different platforms, because this will work with Kotlin multi-platform just in its native module. So if that's something you're looking for, that's really handy. It's got built-in support for Kotlin language features, things like sealed classes. I know it's just ragging on it, but like they do work, and it is being developed so that when the first release comes out, like it will know how to handle sealed classes, it will know how to handle objects, things like that. And according to this thing right here, it's comparable speed to JSON and Moshi, for example. So you're not really losing any advantage in terms of performance. But some of the things that you should be aware of. So again, with the missing, there are definitely bugs, and there's some bugs in the repo. They're getting actively worked on and fixed, but again, just things to be aware of. Missing features, things like objects, stuff like that. Again, the API is experimental, so it's subject to change as you're sort of going along. And just as I mentioned, the documentation can be a bit misleading in certain cases. So if this was up to me, like my final decision, I don't know. It's a bit of a cop-out, but I think it depends on your use case. So I think we had a situation where, again, using a practical example, we had a situation at work where we just basically had a class that we just wanted to serialize to string and save it to a file. In that case, and it was a Kotlin native project. In that case, this worked great for that because it was really simple. We were able to just serialize our class, save it to a file, everything's great, and we didn't have to add a third-party dependency. I wouldn't go and replace my JSON or Moshi instance with this, like in my production app, just yet. Maybe you're more of a risk taker than I am, but like I wouldn't feel comfortable quite doing that just yet. But I think it shows a lot of promise, and I think like when it hits 1.0, I think it's going to be a real solution for a lot of problems. So if you want to learn more, then there's the I'll obviously post the slides, but there's the GitHub, the actual GitHub repo. It's got documentation, it's got issues, it's got lots of discussion going on. There's a ton of examples that JetBrains have written, so there's a series there, and there's Jake's retrofit converter down there in case you want to use it with retrofit. And thank you so much. I hope this was helpful, and if you have any further questions about it, I know we've got a few other talks coming, so please, I'll be around, so please just come find me or put me on Twitter or whatever. And thank you very much.